Hello everyone, welcome to this new video where we are going to go through find largest value in each tree row. So basically in this program we receive as input a binary tree, and you're supposed to find out what is the biggest value of each level in the binary tree. So before diving into the example, if you're new here, yes, Algo Architect. Here we are doing LeetCode daily hackering solution. So if you're interested in any of those topics, don't hesitate to subscribe. You don't miss what you're doing here. So let us take first some example. We can see that at the first level, the maximum element is 1. It's the only element, so it's the maximum. At the second row we have the maximum, which is 3. Here we have 2 and 3, and the maximum is 3. And on the third row we have element, and the maximum is 9. So given those example, how are we going to solve it? What will be our approach of solving this? So to keep it simple and straightforward, what I will do is that I will tie each element to the given row that the element belongs to. I know that if you belong to a node I, then your children are going to belong on the node I plus 1. So that is what I'm going to leverage to make this happen. So I'm just going to create my helper function and saying that the root is at level 0. And then what I will say is that if, like in my helper, if the element doesn't exist, like if the node is null, there's nothing to do. Now in the case it's not null, what I need to do is that I need to put that element in my different element. And what I would do is that if the element, if you already have an element tied to that zip in our map function, then we are just going to replace that value with actually the maximum value between the element that was there already and the upcoming element. And if there is no element attached to that row, actually I'm just going to say, okay, this element is actually the maximum. So you just need to say, okay, at this zip, this is the value. And after that, you just return the helper with the g plus 1 and the g plus 1 from the left and the right. So they're going to come back here. If it's null, they are going to do nothing. If it is not null, they are going to say, okay, you are going to with zip, I'm going to zip x, and then at that zip, is there already someone? If there is no one, then I'm the biggest. If there is someone, I'm going to compare with that one, and then we are going to take the maximum. So that is the idea behind the helper function, and you just call the helper function with the root and a dip of 0. And after that, you're now going to loop through the element of the helper function to have the various value that you are going to return, because the helper function is actually keeping the value at each node. It will say at node 0 we have 1, at node 1 we have 3, at node 2 we have 9. Now you need to flatten that and return it. So let us submit for this first approach and see what it gives. Okay, so this was the first approach of solving this, which is performing in 11 seconds. Let us see now the second approach. So this second approach is basically using almost the same idea as the first one, in the sense of we are still going to store the node with their zip, but this time we are not going to use recursion, but we are going to use a queue, which is going to act like the data structure, where we are going to place all the elements that we need to visit. And whenever we are visiting an element, we are going to perform this. We are going to say, okay, we are visiting this element at zip 1. Do we have actually a vector that has a size which is actually greater than 1? No. If it's not the case, we push the element. That means it is actually the first element corresponding to that level. And otherwise, that means, okay, we already had an element at that level, so we just compare with the maximum. And then once you are okay with this, you just need to push if you have a left element, you push the left. If you have a right element, you push the right to your node, and at the end this result is going to have the list of the largest element of each level. So these are my approaches of solving this. Let me submit this also so we see. These are my approaches of solving this. I hope you do enjoy it. Feel free to give me any feedback. I'll be really happy to interact with you regarding this. They are performing actually almost the same, whereas they were performing like 7 seconds just a couple of minutes ago. I don't know exactly, but this was my approach to solving this. I hope you do enjoy it. Feel free to leave me any input. I'll be really happy to interact with you regarding this. See you tomorrow with new challenge. Ciao.